Hello friends, today we are discussing CBR test, California bearing ratio, how to determine CBR of a soil sample in the laboratory. In CBR test, a plunger of 50 millimeter diameter is penetrated into the soil and the load required to penetrate up to 2.5 millimeter and 5 millimeter penetration level is calculated or estimated in the test. Then this load is expressed as the percentage of standard load corresponding to these penetration levels. That is CBR value. So CBR value of a soil or of a material is the load carried by the sample at 2.5 millimeter penetration divided by standard load at the same penetration level, or load taken at 5 millimeter penetration divided by standard load at 5 millimeter penetration. And this CBR value is important because it is used in design of pavements, flexible pavement as well as in rigid pavement. In flexible pavement, CBR value is required to determine the MR value of the soil subgrade, and in rigid pavement, it is related to the K value of subgrade, that is modulus of subgrade reaction. This test is prescribed in IS code 2720 part 16. For conducting this test, you need some apparatus, some equipment, and these are shown here. You need a tray for taking the soil, then a mold with base plate and stay rod and wing nuts, a collar which is 50 millimeter extension above top of the CBR mold, a spacer disc, metal hammer as per standard dimensions as specified in IS 9198, and this rammer is 2.6 kg for light compaction and 4.89 kg for heavy compaction. Height of the fall in case of light compaction is 31 centimeter, and in case of heavy compaction this is 45 centimeter. Then you need a beaker for measuring water quantity, a spatula for mixing the soil, a straight edge or knife for leveling the specimen edge after the compaction, the weighing machine, 2 filter papers. You also need 2 IS sieve, one of 90 millimeter size, another 4.7 millimeter size, a expansion measuring apparatus, adjustable stem with perforated plate, and tripod having a dial gauge at the tripod. Then you need a testing machine, CBR testing machine with a capacity of 5000 kg and equipped with a movable head or base enabling penetration of plunger at 1.25 millimeter per minute. This test may be conducted either on undisturbed sample taken from the field, or it can be on remoulded sample prepared in the laboratory. IRC 37 and IRC SP 20 both suggest that CBR test should be conducted on remoulded sample in the laboratory. But in case it is required to be conducted on unmolded sample or undisturbed sample, then in that case the CBR mold, the steel edges of CBR mold is used to extract the core from the field at the field density and field moisture content. In case of remoulded sample, the CBR test is conducted generally at optimum moisture content and maximum dry density, and therefore it is important to determine the OMC and MDD using Proctor test. In case of low volume roads, we use light compaction, and in case of high volume roads, we use heavy compaction. And it is explained in part 7 or part 8 of IS 2720 how to conduct Proctor test. I have uploaded another video on Proctor test, and you can watch that video to understand how do we determine the optimum moisture content and maximum dry density of the soil. After determining OMC and maximum dry density, then CBR mold can be prepared either using dynamic compaction or using static compaction. In case of static compaction, exact amount of soil is calculated knowing the OMC and dry density. Say for example, size of the CBR mold is 150 millimeter dia and 127.3 millimeter height, giving a volume of 2250 centimeter cube. And let us say that the dry density, maximum dry density from Proctor test of a soil, you get 1.98 gram per centimeter cube. So amount of soil required, dry soil required to make one CBR mold will be 2250 into 1.98, that is 4455 grams, or you can say 4.455 kg. And if the OMC of this soil is, let us say, 10.1%, then take 10.1% of this, that will be 450 gram or 450 ml of water. So that is how you can calculate exact amount of soil required to prepare one sample of CBR and the amount of water to be added at OMC. If you are finding the CBR at some different density, let us say 97% of the Proctor density, accordingly you take 97% of this density and calculate the soil mass and then calculate what is the moisture content required. CBR test is conducted on material passing 19 mm sieve. If the amount of material in a sample of size larger than 19 mm is in significant quantity, then you replace that quantity above 19 mm size by equivalent weight of the size passing 19 mm and retained on 4.75 mm sieve. So in case of dynamic compaction, we take about 4.5 or 4.5 to 5 kg of soil in a tray and find out how much water is required corresponding to OMC. Mix this water into the soil. Use a spatula to mix the soil initially and then use your hand to mix water and soil till it is uniformly mixed and you get uniform color of the soil. Then you divide this soil into 5 almost equal parts. Prepare the specimen. Now you have the mold with base plate. Place the spacer disc here and a filter, and then collar also. You attach the collar which will give you 50 mm extra space for compacting the soil. Now you put the first part of the soil into the mold and then give 55 blows of this hammer. Now after the first layer is compacted with 55 blows, just make a scratch on the surface and put another layer of the soil on that. Again do it the same thing, compact it with 55 blows and keep on doing till the last layer is compacted. Then remove the collar and remove the extra soil here. Trim the compacted soil carefully by means of a straight edge and remove the extra soil, and any hole that may be there on the surface of the compacted soil by removal of the coarse material should be patched with small size material. Remove the spacer disc now and place one coarse filter above the base plate. On perforated base plate, invert the mold and the compacted soil and clamp it to the perforated base plate. Now keep a surcharge weight of 2.5 kg on this compacted specimen to simulate overburden and then place this in the water. And for measurement of the swelling index, this tripod with a dial gauge is kept on the edge of the mold and take the initial reading of this dial gauge. That is how we prepare the specimen using dynamic compaction. But what IRC 37 suggests that the CBR mold should be compacted using static compaction. And in case of static compaction, as I told you here, you know the maximum dry density, you know the volume of the mold, calculate how much amount of soil will be required to prepare the specimen of 127.3 millimeter height. So you now have the exact soil, exact amount of soil and exact amount of water. In case of static compaction, you take exact amount of soil and water, mix it properly as we have done in case of dynamic compaction test, make it uniform mix of soil and water, and again you divide this soil into 5 layers, 5 parts, put the first layer and give slight compaction using a hammer here, then put another part of the soil, again make a light compaction here, and finally you place the entire soil into the mold. After the final piece of or final amount of soil, care should be taken that no part of the soil is wasted because it is exact amount of soil you have taken initially. So entire soil is to be put in the specimen, give the final level of compaction here by hand, and then here you don't need to provide collar. Then you place the spacer disc here, put in the compaction machine, and idea here is to compact the soil until this spacer disc is completely in line with the edge of the mold. So you just put a small plate between the spacer disc and the machine, and then apply load at a slow rate till the entire this spacer disc enters into the mold. That is how we do static compaction. So slowly this spacer disc will go inside the mold, and finally it is completely in, and that is how you achieve the compaction, the density corresponding to OMC, maximum dry density. After that, you just release the specimen, take it out, and this is now the same specimen which you got through dynamic compaction. Reverse it and then remove this extra soil, whatever you get here, and then you again put the dial gauge with tripod for measurement of the swelling index, put in the water, and this is soaked in water for 96 hours, that is 4 days. After 4 days of soaking of the specimen in water, you take out from the water tank, remove this dial gauge, take the final reading. So for dial gauge, you take the initial reading as well as the final reading after 96 hours. Drain the extra water by putting it in the inverted position for 15 minutes, and then remove the spacer disc. Now put in the machine, CBR machine, and you make a surcharge here, and inside the surcharge you put the plunger. Now this plunger is fitted into the CBR testing machine. This machine has 2 dial gauge, one is for load, another is for measuring the penetration. The plunger is now seated under a load of 4 kg so that full contact is established, and after that you just make both dial gauges 0 and then apply the load at a rate of 1.25 millimeter per minute. That is how it is tested. And then you determine the load value at different penetration values. Penetration values are 0.5, 1, 1.5, 2, 2.5, 3, 4, 5, 7.5, 10 and 12.5 millimeter. That completes the test. Now you have the load and penetration value. So make a graph between load and penetration. Now you have load for a penetration of 0.5, 1, 7.5, 10 and 12.5. Corresponding to these penetration, these are in millimeter, you have load values. Now you make a plot on simple graph paper. This is the penetration in millimeter and this is the load value in kg. Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. These are in millimeter and you have load here. Let us say 50, 100, 150, 200, 300. It all depends upon the type of soil. Some soils will take more load, some soil will take less load. Accordingly, you make the scale here. Ideally, this graph should be like this. It should have a concavity upward. But in many cases, you will find that when you plot load penetration graph, you get a concavity in the beginning and then it goes up like this. Now, this concavity here may be because of several reasons, but the most prominent reason is that initially your top surface of the soil is soft and penetration is more, load is less. Or maybe sometimes your plunger is not in perfect contact with the soil surface, so penetration is there and there is no load. So that creates the concavity here. So in that case, you need to apply certain correction to this curve. And correction here is that you draw the tangent here from the point of maximum convexity. So that is the tangent here. Now this point here where it cuts the x-axis, this is considered as the new zero. And all penetration values are measured from this. So 2 millimeter penetration or 2.5 millimeter penetration, which was here earlier, it will shift by this amount laterally and it will be here 2.5. Find out the load value for 2.5 millimeter penetration and corresponding to 5 millimeter penetration. Now these two loads are important to determine CBR value. CBR is estimated at 2.5 millimeter penetration, load at 2.5 millimeter penetration divided by standard load, and standard load is 1370 kg multiplied by 100. This is CBR value. CBR at 2.5 millimeter penetration. And similarly, CBR at 5 millimeter penetration will be load corresponding to 5.0 millimeter penetration divided by load. Now this load is now 2055 kg. That is CBR at 5 millimeter penetration. Generally, CBR at 2.5 millimeter is higher than CBR at 5 millimeter. And that should be accepted. The higher value should be accepted. But if during your experiment CBR at 5 millimeter is coming higher than CBR at 2.5 millimeter, then in that case what IS code suggests that the test should be repeated. And after repetition, If you again get the higher value at 5.0 millimeter penetration, then accept the higher value. Now to find out the swell in the soil is 100 into df minus di upon h. df is the final dial gauge reading minus initial reading of the dial gauge initially at zero swell. df is the final reading after 96 hours. H is the thickness of the specimen, that is 127.3 millimeter. That is your swell index. That basically indicates the swelling property of the soil. It will be high in case of clay, very low in case of sandy soils. So that is how we do CBR test in the laboratory. Thank you very much for watching this video. If you have any question, you can write in the comment box.